Hello, everybody. How is everyone doing? It is April 30th today, and we just heard this week that schools are going to be closed until at least May 31st. So I hope you're doing well, and I really, really mean that in terms of not math, but life. Um, This has been a struggle for me, and I'm sure you're facing your own challenges. And I just want you to know that I've been thinking about you guys a lot, and I really, really hope you're doing well and finding ways to stay sane. Anyway, um, yeah, I'll be posting weekly check ins for you guys to check in with me if you'd like. Okay, math. This is cycle three. This is the second lesson. Last lesson, we created equations in the form of the factored form using a point and the zeros. Today, we're going to do the same thing, except we're going to make equations from a point and the vertex. Okay, so I'm going to go into presentation mode here. Da, da, da. I feel like my internet is grinding to a halt. Okay, here we go. Okay. So our learning goal for this unit is to create a quadratic equation in vertex form from the vertex and a point on a parabola. So first of all, let's review what vertex form looks like and then what each variable tells us. So we did this last cycle. We looked at this equation. So this is vertex form, y equals a times x minus h all squared, so that whatever in the brackets gets squared, and then plus k on the outside. And now let's just review what each one of these means. So a means the same as it did in the factored form. So it tells us how much the parabola is vertically stretched, and the sign of it gives us the direction of opening. So if it's a positive number, it opens up. And if it's a negative number, it will open down. Now, h and k, h is the x value of the vertex. So if you have a positive x value, it will look like x minus h, right? Because if I have my vertex, my x value of the vertex is 3, it's going to be like x minus 3, and it will move to the right. And if we have a negative value of the vertex, let's say -3, if you put an x minus -3, it becomes x plus h. So the sign is kind of the opposite sign you might think. And so if it looks like this, it's going to move to the left. K is the y value of the vertex. So if you have a positive number there, it's going to move up. And if you have a negative number, it's going to move down. Okay, so let's do some examples. These are going to follow the very same steps as we did in the last lesson, except we're going to be using the vertex form of the equation rather than the factored form. So well, let's say we have a parabola given to us. So we have the point of the vertex, and we have some other points too. So that's going to help us. Now, just so you know, you only need the vertex and one other point. You don't need more than that to do this kind of problem. So step one is to insert our vertex coordinates into the vertex form of our equation. So just a reminder, here's the vertex form. So y equals a times x minus h squared plus k. Now, remember, h is the x value, so h is going to be -2, and then k is the y value. K is going to be -3. So if we put those in, I'll put h in brackets just so it's easier to see. So x minus -2 and then plus -3 So let's just make that a little nicer. You can go straight to this step, of course. So this is our equation here, because if you subtract a negative number, you're going to add it. And then if we add a negative number, you're going to subtract it. Now, this is our basic equation, but we have to figure out what A is. How much is this parabola stretched by from its normal um, rate, normal size, sorry. Step 2 then, to find our A, we're going to substitute in one of our points for X and Y. So I'm going to choose 1 and 3 because they're both positive numbers, and I find positive numbers easier to work with, but it does not matter what point you put in. You will still get the same answer. And that should be 1 comma 3. Okay, I'll fix that later. Okay, so if I put in 3 in for Y and 1 in for X, we get 3 equals A times 1 plus 2 squared minus 3. So now we're going to simplify that expression and do algebra to find our A. So 1 plus 2 is 3 squared, and 3 squared is 9. So we get 3 equals 9A minus 3. To get rid of this 3, we have to add it to the other side, right? You do add it to both sides, but I like showing it this way. So 3 plus 3 equals 9 times A. 3 plus 3 is 6 equals 9A. And then to get rid of this 9, you're going to divide by 9 on both sides. So you would get 6 over 9, but that reduces to 2/3. Okay? Actually, I might put that here. So I'm going to do a couple things here just so you see that step. So 6 over 9 equals 2/3, which equals A. That way you can see where that comes from, okay? Just going to go back in here and go through all that again. So then, once you have your A value, you can put that back into your equation. If you want this as a fraction or a decimal, either way is fine. Just know that fractions are more exact. So if you can put it as a fraction, you can, but if you put it as a decimal, I wouldn't mark it wrong. Okay, so there's our final equation for this. And again, just like last time, if you throw it into Desmos, you can check your answer. So if we throw it into Desmos, we can see our vertex is -2, -3, and it does go through the points that we had. So 1 and 3 here, that's what we put in, and -5 and 3 was another point on this one, right? And it matches, so that's good. So remember, always use Desmos, or I should say you can always use Desmos to check your answers. Okay, here is a second example. We're going to find an equation of a parabola with a vertex of 3 and 4 and a y-intercept at 23. So we're going to follow the same steps. So insert our vertex into our vertex form. So there's our vertex form equation. Remember, our h is our x value, is 3, and our k is our y value. So our equation becomes a times x minus 3 squared plus 4. Now, we're going to substitute in a point for x and y. Now, we're told what the y-intercept is. So we saw this kind of example in the last lesson. So remember, if it's a y-intercept, x is 0 and then y will be 23. So that will be the point we can put in. So 0 will go in for x and 23 will go in for y. And now we have this equation. And now we can do our algebra. So 0 minus 3 is -3, and -3 squared is 9. So we end up with 23 equals 9 times a plus 4. Now we have to get rid of this 4 first. So subtract it on both sides. 23 minus 4 equals 9 times a. 23 minus 4 is 19 equals 9a. And then you're going to divide both sides by 9 to get approximately 2.1. Or you can leave it as 19 over 9. That's fine too. Step 4, you're going to put your a value back into your equation from step 1. So your final equation there is 2.1 times x minus 3 squared plus 4. Now, if you do use a decimal like I have done here, when you graph it, it might not be exactly lined up with these numbers. You will get the correct vertex because the vertex is here, right? This will tell Desmos what the vertex is. But the y-intercept might not be exactly 23 because I had to round this a bit. So see how when I graph it, the y-intercept is 22.9. If you had graphed it as 19 over 9, you would probably get the exact intercept. But if you do this, it's okay if you're rounding the decimal, that's fine. Okay, well, this should be example 3. And I think this is the last example, I believe. So this is just, you have the vertex and you have a point. Okay, so same steps, insert your vertex into the vertex form. So your x value of the vertex is h, so that's going to become -3, and k is your y value of the vertex, which is going to be 2. Okay, we're just going to clean this up a little bit. If you have minus a negative number, you're going to add it. And there's our equation, but we have to find a, so we're going to sub in our point to find a. So our point is -1 and 4. Put your -1 in for x and your 4 in for y. And we're going to do our algebra. So -1 plus 3 becomes 2. 2 squared is 4, so we get 4 equals 4 times 8 plus 2. Need to get rid of that 2, subtract 2 both sides to get 2 equals 4a, and then we're going to divide by 4 on both sides to get 1/2 equals a. So our last step again is to put that 1/2 value as our a into the equation that we got in step 1. And there is our final equation. And again, you can plot it in Desmos to make sure that it matches. So our vertex is at 1, 2, 3, -3 and 2, right? Okay, and does it pass through point -1 and 4? -1 and 4, yes it does. So that's great. Okay, so here are the you try questions. Questions number 1 to 12 of cycle 3, day 2 in the practice booklet are the questions that are like these. You do not have to do all of them. If you do the first, 2 and you're getting it, you don't have to do the rest of them. If you feel like you need more practice, definitely do more. But there's no need to do all 12. They're all the same type of problems, so you're not going to lose out if you don't do some of them. I have posted my full solutions, so my written out solutions on Brightspace. Once you're comfortable with that, you can go ahead and do 3.2 quiz on Brightspace. All right, that's the lesson for today. And I will talk to you next time, guys. And please check in if you have the time with me. Send me a message using Brightspace or on email, anything like that. Okay. I miss you guys. Bye.